There will be some occasions when we want to solve a system of 3 equations using substitution. And those times will be when the system is set up to make substitution easy. These systems that are easy to solve by substitution actually come up in a lot of really common applications. So here's a very simple example of an application that's going to give rise to one of these systems that are easy to solve by substitution. And I give you this example so that you see that this kind of system actually occurs in real problems. So in this story, Alice, Bob, and Carol are splitting a dinner bill. Bob ordered something expensive, so he'll pay $5 more than Alice. Carol is also paying for Dave's meal, so she'll pay twice as much as Alice. And the total bill is $65. We want to know how much each person needs to pay. Now, obviously in this problem, the numbers have been chosen to make the arithmetic easy. If you go out to dinner with mathematicians, this sort of thing really happens. Of course, the real application for this is a more sophisticated sort of resource allocation problem, which might have 57 variables instead of only 3. But the same principle applies, and we get this really common kind of system where Bob pays $5 more than Alice. So what Bob pays is what Alice pays plus 5. Carol is paying twice as much as Alice. So what Carol pays is twice what Alice pays. And the total bill is $65. So all 3 added together is 65. The reason that substitution is going to be easy in this problem is that equations 1 and 2 express B and C in terms of A. So we can plug 1 and 2 into 3, replacing B using equation 1 and C using equation 2. That'll give us the equation A from the original equation plus B from equation 1 is equal to A plus 5 plus C from equation 2 is equal to 2A, and that all equals 65. Really nice. In one step, we went from 3 equations with 3 variables to 1 equation with 1 variable. We're very lucky here. We usually won't be this lucky, even when we do have an equation that makes substitution easy. But now here, the parentheses aren't doing any work. We can drop them, combine like terms, and we have 4A plus 5 is 65. 4A is 60. So A is 15. Alice is paying $15. B is A plus 5, so 15 plus 5 is 20. C is 2A, so 2 times 15 is 30. So apparently, Alice pays $15, Bob pays $20, and Carol pays $30. To check, if we add all of those up, we really do get 65. We're not going to make mistakes at these 2 steps. We might have made a mistake at an earlier step, but just checking equation 3 will catch that now. Okay, so this system was set up in such a way that substitution was very, very easy. In the next video, we'll see a couple of examples where substitution is easy, but not quite this easy.